Hello, everybody. This is our second little foray into algebra. Don't worry about this 8.2. It doesn't make any difference. We're talking about radicals in this lesson, and the radical symbol is this symbol. And for our purposes, what this means is called, you think of it like a square root. It means more than that, but for today, we're just going to talk about square roots. And this means what you do with this is whatever's underneath it, this expression with something underneath it is equal to the thing you multiply by itself to get the thing underneath it. So what do I mean by that is this. Given a number underneath it, like the square, this is like, I would read this as a square root of 36. You say to yourself, what number times itself gives you 36? What number multiplied by itself gives you 36? And you can like think about it for a minute, and if you think about it long enough, you'll realize that this is the square root of 6 times 6. 6 times 6 is 36, which means that equals 6. Another way to write that, maybe one more step. I wouldn't do this every time, but just as we're learning this, it's a good idea. 6 times 6 is also known as 6 squared, 6 to the second power. That equals 6. And what you notice is that the square root of something and something squared like cancel each other out. When you see the square root of a number squared, you can cross off the square root symbol, the radical symbol, and the exponent 2, and you can write it as just 6. So in a similar way, I think of this, you're like, what number times itself is 121? There might not be one, in which case you can't simplify it, but here you can. 121 is 11 times 11. You notice I wrote the negative sign. I just rewrote it on the outside. The square root of 11 times 11 is 11. Just like up here, we had the square root of 6 squared. I'll write this one more time this way. 11 squared. The square root symbol and the squared cancel each other out, and you're left with just the negative sign again. It doesn't go away. And then 11. So the square root of 11 squared is 11. Square root of 121 is 11. 1024 is maybe less obvious, but it's 32 times 32. So that's the square root of 32 squared, which is 32. So again, you don't necessarily have to write all the steps in between here, but you should know that that's why this turns into this. The square root symbol and the squaring, the exponent here, they're called inverse functions, but basically you can think of it as them just canceling each other out. Square root symbol and 2 cancel each other out, and you're left with just 32. You should know at least the first 10 or 15 or so perfect square numbers. These should be things that you don't have to think too much about. I'm not going to recommend you guys memorize too many things ever in math, but you should memorize some of these perfect squares. So maybe up to 12. Let's see where people go. So 1 squared is 1. 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. We saw that one up here. And 12 squared is 144. If you memorize those first 12, you'll be in good shape for now. It's not a bad idea to memorize some more, but up to the first 12 is probably good. So the numbers here on the left side, these numbers, 1, 4, 9, 16, 25, all those are known as perfect squares, which means you can multiply a number, an integer by itself, and you get one of those numbers. That's what I mean when I say a perfect square. So you can see right here, those we can do, and by those I mean like these ones, 36, 121, 1024, we can do because the numbers, by this I mean the number inside the radical symbol, are perfect squares. It's like exactly 32 times 32. Other numbers are less obvious. That's true. Like 18, if you look up at our list of perfect squares, is not on our list. We go from 16 straight to 25. There's no whole number, like 4 or 5 or 6, you can multiply by itself and get 18. So we're going to use what we call the product rule for radicals. Product rule. This word means multiplication. And so the product rule says, it says both of these things. It says if I have two radicals and I multiply them, I can multiply the things underneath one single radical. Like I can put the A and the B multiplied underneath one. And I can do it the other way too. If I have two things multiplied underneath one radical, I can write it as the square root of the first one times the square root of the second one. So basically, if I'm multiplying, this does not, it works for multiplying and dividing. We'll see that in a minute, but this does not work for adding and subtracting. I can't emphasize that enough. It does not work for adding and subtracting. What I mean by that is, if you want to do this, this does not equal the square root of A plus the square root of B. This is important to me that you know this. It's like a basic fundamental thing about these square root symbols, that you can split them up like this. Like you can take this product in here and make it a product on the outside. And you can do it if it's divided. We'll see that in a minute, but you cannot do it for adding and subtracting. It does not work for adding and subtracting. So we call this the product rule, and we can use it to simplify things that look like the square root of 18 sometimes. So the trick is, well, here's just some examples of the product rule first. Since these things are multiplied, it means I can take this, I can make this as the square root of 2 times 3. I put the two numbers on the inside multiplied. 2 times 3 is 6. So that's the square root of 6. This is the square root of 7 times 5. That'd be the square root of 35. This is the square root of 11 times A, which is just the square root of 11A. Doesn't matter what A is, it's just a variable, it's just sitting there. If I get the square root of 31 times 31, we actually saw in those first examples, this is 31 times 31 is 31 squared, which means you can cross off the square root and that second power, and I get 31. Just a quick note about this canceling. If it was the square root of 31 cubed, you can't cross this off in that exponent. You can only do this crossing off if the exponent is 2. And we'll see some more simplifying at some point, but for now, understand this only works if the exponent is 2. If it's a 3 or 4 or 5 or anything else, it doesn't work. You can only cross these things off like this if the exponent is 2. Like this does not equal 31. You can't just cross those off, because the exponent here is 3 and not 2. So this example again, and this is like the basic thing that we're learning here, is how to simplify these. You look at the factors of this number, and I think of it as it's 2 times 9, and this is a perfect square. So you think of it like 9 is 3 times 3. And now this number has no more factors, so we stop there. Sometimes people put a circle around it. You put a circle around these two as well. And so that's 2 times 3 times 3, which is the same thing as 2 times 3 squared. And that's good, because I know that somehow I can cross off the radical and the 2, but like the product rule says I can do it like this. I have the square root of 2. I can write this as the square root of 2 times the square root of 3 squared. Like I can split this thing up into 2 parts. That's what the product rule said. It said, if I have the square root of something times something else, I can write it as the square root of the first thing times the square root of the second thing. And I know now I can do my little trick here, like this root and that 2 cancel out. And I'm left with the square root of 2 times 3. And this is always written with the number before the radical. It's always written. You know, people don't leave it like this, they write it like this. It's just very common. It doesn't really make any difference. These things are exactly the same. But you should write it this second way, because you're just not going to see it written like this very often, and I want you to get used to recognizing it this way. So it's 3 times the square root of 2. 3 square roots of 2. Yeah, that's the square root of 18. That's how we simplify radicals. We basically look for this perfect square factor that's hiding inside 18. That's the thing that's important to us. 18 is 2 times 9, and the square root of 9 is 3. And that's where this 3 comes from. So it's important to kind of see that what we're looking for when we do this factoring is perfect squares that are parts of these numbers. So there's there's a million of these possible. There's so many examples here. So like I said before, the trick is to look for factors of the numbers that multiply to make the one under here that are perfect squares. So I think of 32, this is 2 times 16, and this is one of my perfect squares. So it's the square root of 2 times 16, which is a square root of 2 times the square root of 16. The square root of 16 is 4. So we get square root of 2 times 4, which you should write your answers like this. I'm going to ask you to write your answers like this. Don't write it like this, write it like that. Know that they mean the same thing, but this is, so your final answer should look like that. So to walk you guys through that again, when I have a number under here and it's not a perfect square, if you go back to the list, you'll see that 32 is between 25 and 36, which are on the list, which means that this is not a perfect square. So I can write it as 4 times the square root of 2. I look for factors of this number that are perfect squares. In this case, it was 16. I do the square root of 2 times the square root of 16. The square root of 16 is equal to 4. And then I write the 4 in front. It won't always work. Like sometimes you'll do factors of this thing and you won't ever find a perfect square, in which case you have to leave it. But a lot of the ones I'm going to give you, you'll be able to simplify because I want to make sure you know how to do it. This one, 50 divides by 2 and you get 2 times 25 makes 50. And this is on my list. The square root of 25 is 5 because 25 is equal to 5 times 5. A lot of people, I see students like making whole factor trees and then they take out pairs. That's fine, you can do that too. I kind of like this way though, because I feel like it takes less work. 2 times 25 is the square root of 2 times the square root of 25. The square root of 25 is equal to 5. So this is 5 root 2. The only thing I didn't do in this problem, which I did in the one above, is I didn't write this one step. I removed that one. I could see this was 5. And I knew that it had to be in the front, so I just wrote it in front immediately. So 5 root 2. That's what the square root of 50 is equal to 5 times the square root of 2. We can do that for all of these. We'll do a couple of them at least. 8 is 2 times 4. I can write it as the square root of 2 times 4. Square root of 4 is equal to 2. So this would be 2 root 2. 30 is a little different. We look, it's 2 times 15. That's not a perfect square. That's not a perfect square, so I keep going. 15 has more factors, 3 and 5. But like nowhere, now I'm done. This has no more factors, this has no more factors, and this has no more factors. So like I can't simplify anymore, and none of these things are the same, and none of them are perfect squares. So this cannot be simplified. You just write the square root of 30 again. Cannot be simplified. Let's see, 96, 2 times 48, that's true. Not a perfect square, but it is, that's done. And that's not a perfect square, but it still has more divisors. 2 times 24, that's done. This is not a perfect square. 2 times 12, that's done, not a perfect square. 2 times 6, that's done, and now this is 2 times 3. So there's like 2 times 2 times 2 times 2 times 2 times 3. So it's like 2 times 2 times 2 times 2 times 2 times 3. This is a little trickier, I think. And what you'll see is like, this is a 4 right here. 2 times 2 is 4. Those two are 4. These two right here are 4. And those two right there are 6. So this is really 4 times 4 is 16. So that's really square root of 16 times 6. And the square root of 16 is 4. So this is 4 root 6. So that's a fine way to do that one, though I probably, if someone asked me, I wouldn't do it that way. I would probably think about it more like this. I'll do it over here. Square root of 96, and I would look I just look at all the factors of this number. 1 and 96, 2 and 48, 3 and 32, 4 and 24, 6 doesn't work, 6 and 16, 7, 8 goes into it, 8 times 12. That's it. And I'd look on this list I just had here. Are any of these numbers perfect squares? No, no, no. That one is. So I'm gonna keep an eye on that. I keep going. No, no, no. That one is. No, 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 no. So what I want to do is pick the biggest one, the biggest perfect square I found, and that was 16. So I'm going to use this pair. So to write this as a square root of 16 times 6. Square root of 16 is 4, so I get 4 root 6. A lot of people like this trick where they circle the prime factors, is what those are called, and you just you pull these two 2's on the inside, make 1 2 on the outside, and these two 2's make 1 2. But I'm happy to talk to you about that method, but I like this method better. So I'm gonna stick with this way, where I just look for the biggest perfect square factor of the number and then rewrite it like that. I could have done 4 times 24, but then I wouldn't be done. So I look at all the factors and I take the biggest perfect square factor. That requires you to find the factors of a number, but I trust you guys can divide numbers. So that's what we're gonna do. All right, so I'm gonna break this here and then we'll talk about multiplying and then simplifying. And stay tuned for that.